Okay, someone asked me for help on this take home, and I want to share the help that I gave them to you. So let me open up the file. They had a question about, where are you? This first one, or at least this is my first one. You have the potential energy as a function of distance. You've got a matchbox car, it's 5 kg. All right, a student came to me earlier today and asked me for help on a couple of questions, so I want to give you the help I gave to her. So a young lady came this morning and asked me some questions about some of the tougher problems on tonight's take-home. So I'm going to give you the help.
Callan Kennedy, please come to the general office. Callan Kennedy, general office now, please.
So I'm going to give you the help. So I'm going to give you the help that I gave her. This one over here. First thing you should know is all this down here really doesn't help you at all solve it. You have it says a matchbox with a mass of 5 kilograms starts in rest. So at the very beginning it's rest. If it starts at rest, then its KE is 0. Let me make this smaller. KE is 0, so it's all PE. It looks like it's 25 joules. And then it says, what is the velocity? Well, this is about the conservation of energy. You can read off you can see the PE over here is a certain amount. I think it's 15 joules. So if you want to find the velocity, the hint on this one is that the total energy over at this location here has to equal the total energy at this location. What does that have to do with velocity? Well, the other kind of energy it has at D is kinetic energy, so you should be able to get it with that information. Total energy in the beginning, all PE, equals the total energy at D, PE and KE. The KE will get you the V. Then this person also had a question about this right here, and it said that what is the velocity down here? Know that at the bottom it's KE only, it has no PE, but here it has PE and it has KE. Why do I know that? Because it said it's moving, so it's the KE down. Same thing, conservation of energy. The PE and the KE here equals the KE down there. And what else did I think there was another one over here. Here's the next question that the last period asked me about a Spalding baseball that had a mass of 2 kilograms. It's thrown upward at 10 meters per second, and it lands at only 5. How come it lands at only 5? How come it doesn't have the same velocity when it comes down? Well, I should say same speed, because it lost energy. Well, what kind of energy did it have when it was thrown up? Only KE. What kind of energy does it have at the bottom? Only KE. Why are they different? Well, because of the energy lost due to air resistance. So I would use that to help me solve it. So the KE at the beginning doesn't equal the KE at the end because I've lost some energy due to air resistance. So that's the hint on that one. And then I have one more, not hint, but clarification. Someone came to me also at the end of the day. I'm going to give you the clarification that she got. It's about the football problem. Let's find it. Here it is right over here. Yeah, to prevent being tackled 100 kilogram Tampa Bay football player runs at 6 meters per second, and 150 kilogram player from the Jets leaps, running 7 meters per second, leaps and grabs onto. It's not clear that they're both going. This only works. You won't get a solution unless you know that they're going in the same direction. Now, I think they were not clear about that. That both the 100 kilogram Tampa Bay football player and the Jet player were both going in the same direction. This is an inelastic collision. Think about momentum, what momentum is like before and after, and there you go. That's all the help I'm giving you. Good luck. Don't submit it till you're really sure. It's due 11:59 tonight. Goodbye. Good luck.